Hi everyone. Welcome to the Advanced Unity webinar. In this webinar, we're going to be doing some pretty cool stuff. I noticed that most of you guys didn't actually attend the last Unity webinar where we showed setting up the Unity environment. So we'll go through that really quickly. If you feel that it moves a little too fast, you can always refer to our previous webinar where we took more time and went into more detail setting everything up. After the Unity environment is set up, I'm going to show you how to create a 3D map. We took a nice little video this morning showing both precision and instant tracking. I'm going to show you how to bring those maps and put them into Unity. Then we're going to add a couple of different models, and we're going to show you how to turn one of them into an occlusion model. So with the 3D tracking, we're going to be tracking a chessboard with a couple of pieces on top. And what we want to do is we want to have our Metaio man model look like if he walks around the back of the chessboard, we want him to basically be invisible wherever the chessboard actually is, so that it looks like he walks around behind it. So we're going to be doing occlusion models. We're going to add some very simple interaction with the Metaio man. We're just going to add a couple of buttons on the page that let you move him back and forth so that we can walk him around the environment. And then we're just going to wrap everything up. We're going to build the project. I'm going to show you a couple of things that we need to do in Xcode. And then we're going to run the project. After that, we have a new Unity SDK release coming up in the near future that has some really cool new functionality. So I'm going to quickly touch on the roadmap, and then we're going to wrap up with a live QA session. So if you have any questions during the webinar, feel free to just ask them to the organizer, and then those will all be collected, and at the end I'll go through and answer anything that happens to come up. So let's, without any further ado, we're going to get started. So we're going to come here, and we're going to create a full new project, and we're going to call this Unity Webinar 2. Don't care about saving the old scene. Close that. So here you can see we have a completely empty project. The very first thing that we need to do is we need to import the Metaio Unity package right here. So you'll need to go to the Metaio website, download the Metaio SDK, and then simply navigate to the Unity folder and launch the Unity package right here. This will give you a list of options to import everything. That's quick and easy. Now you'll notice that we have three folders over here in our project view. We've got the resources folder. This is where any of our tracking data goes. So after we create the 3D tracking map, we're going to put it right in here. We have the plugin folder, which we're not going to worry about right now, and we have the Metaio folder where most of our content is sitting. If we open up the scenes, you'll see that we have a single AR scene right here, and we're going to launch that. We don't care about saving the untitled scene that we're in. And you can see that we have this lovely character right here. Down here on the left, you'll notice that we have two basically parent objects. We have the Metaio SDK with the camera associated. For this, it needs a tracking signature or an application signature and some tracking data. We're going to get back to both of those in a minute. And then the Metaio tracker here actually has the Metaio man sitting underneath it. So the Metaio man is associated with this specific piece of tracking data. Okay, now a couple of things that we need to do in the very beginning are we need to go to File, Build Settings, and we need to add the current scene to the build settings. Otherwise, nothing is going to be built when we actually try to run the project. Next, this demonstration is for iOS. So we need to select iOS here and click Switch Platform. This will take just a second. There you go. And then we're going to click on this player settings button here. So close this. You can see that we have this required bundle identifier here. This bundle identifier lines up with the application signature that we saw on the Metaio SDK previously. You do that by going to our development portal. I've already logged in here, and you create a new application, and you give it an application ID. And after you've created that, you'll instantly get an application signature and an application identifier. The application identifier we're going to copy, and we're going to put that in the player settings here. That goes in the bundle ID field right there. So you can see that that's real easy. That's the only thing we really need to do there. Then we come back to the Metaio SDK, and we're going to copy this signature right here. Be careful when you copy this. Occasionally, if you just like double click to select it, you'll notice that the equal sign might not get selected. So make sure that you get all of the content. Otherwise, any little errors like an extra space or a missing equal sign will mean that your application will be invalid. And when you try to run it, you're just going to get a plain blank white screen. Obviously, you don't want that. So make sure that when you paste it in, you don't have any extra, spaces at the end or anything like that. Cool. So there you go. That is basically all you need for, and then there's the tracking data right here, which we're going to get to in just a second. This is the basics to getting a very simple augmented reality scene going. If we put in the default tracking data right here, the tracking XML, then build the project, we would see this guy right here sitting on top of the Metaio man marker, which looks very similar to him. And everything would work perfectly fine. But we're not going to use the default tracking data. We're actually going to create a 3D point cloud, and we're going to import the 3D point cloud and use that as our tracking data. So I have two little videos here for you. With one of these, I was using precise marker tracking, which, as you can see, has the markers there. And the other one was using instant tracking with no markers. The reason that I did two of them is because for most situations, actually, the instant tracking is quicker and more accurate and is just easier to use overall. However, because we want to include the occlusion model, unfortunately, there isn't any way currently of importing the point cloud directly into Unity. So let me just launch this for you, and I'll explain a little bit more at the end. Just mute this. So this morning, sorry. So I created this just before the webinar, and I'll walk you through here. So you need to download the Metaio toolbox. Oops. And this lets you create 3D point cloud maps. We're going to change the scale to small for a desktop-sized scene. You can do whole rooms or even building-sized ones, but obviously this is just a small one. And you want to change the maximum point cloud size down. I did 5,000, but you could probably go significantly smaller. Same thing for the precise mapping. Too many points will actually make your tracking less accurate. We then launch the Metaio toolbox. We're going to go to precise mapping. We're going to select the default markers. These are accurate. You can print them yourself. You can email them to yourself and then print them. And they create very stable point clouds. You can also use custom markers or calibrated markers if you want as well. Those are you supply yourself and then you import them. We're going to use the default markers though. And there you go. You can see one of them is there, the other's there, and the third one's there. They're all placed around this chessboard with a couple of pieces sitting on it. And the first thing we need to do is initialize tracking. You can see that the first marker has a green square around it and the other two have red squares. You want to move around until all three light up, like so. And then the more you move around, the more accurate your end point cloud is going to be. So after the tracking is initialized, you should move around for a second or two afterwards. When you hit the continue button, that's when the tracking will actually begin. And you'll see as we move around, a 3D point cloud begins to be built. It takes a second for it to initialize. Oh, there you go. And you can see that the marker 1 is still visible, but the other two markers have dropped out. Don't worry about that. You can also see that this plane is kind of popping into and out of existence. That's because the 3D tracking is being built right now. It's a little bit hard to see, but you can see these red dots starting to appear all over the scene. That's the actual tracking information which is being built. So the more points you get, the more stable your overall scene is going to be. You can see them there a little bit better. And in the top right, you can see what percentage of your 3D map has been created. You don't have to get all the way to 100%. And you can see that after moving it around, I'm going to rewind here just a little bit. No, a little bit further. But you can see that after moving it around a little bit, it's becoming more stable. And we're only at a 13.5% here. This again continues to increase. You don't need to get it to 100%, but the higher the number, obviously, the more stable your tracking is going to be. So a note here, the reason that I chose to use precise mapping for this particular example is because you cannot import this 3D point cloud directly into Unity and actually see it visually. That means that because we're making an occlusion model that that accurately reflects this chess box, we need to know the dimensions of this marker so that we can place this accordingly. If we were just simply overlaying a model on top of it, then we'd be able to use the instant tracker, which I'll show next. So this is a quick demonstration of the instant mapping, which is you don't need any markers for. Simply hold it up, and right away it starts looking for any feature points. You need to move it. Oops, nice view of my feet there. You need to move the screen slightly to the right for it to initialize for the first time. But as you can see, the same points are still being created. And as you move around, you can see that this actually picked up tracking quicker than the marker-based one. You can see that the points exist there in 3D space, and that we have some nice ones sitting right on top of the queen there. So moving around, you'll still have the same percentage bar up in the upper right-hand corner, which I don't know if you can see here. Yeah, there you go, 25%. So you can see that the tracking point cloud was created much quicker using this method. However, because it doesn't have specific center coordinates, it's more difficult to line things up accurately, which is why we ended up using the precise mapping. Okay, so after your 3D point cloud is created, you need to import it. And you can find this on our documentation, but just in case you don't find it there, launch iTunes, okay? And then connect your device. Right here we have the iPad 2 that I was using before. You go into Apps, and then you scroll down and you select the toolbox. You see you can select any different application which you have installed here. But we're going to select the toolbox, and we're going to scroll down until we find the map that we saved. And as you can see here, we have this webinar map.3D map and this webinar map.creator 3D map. These are two, the actual 3D map is the same, but the creator 3D map has additional content. The creator 3D map has snapshots that help you orient the 3D point cloud if you open it in the Metaio creator, which is a drag and drop style augmented reality creation tool. However, we don't need that. We're just going to use the webinar map.3D map. We're going to save this to the desktop. Just a minute. And then we can quit iTunes when we're done with that. One moment, let me find that on my second screen. All right, here we go. So now we have this webinar map.3D map. And I already have this in the webinar folder, so we're just going to delete that guy right there. Okay, so now we have this 3D map. What do we do with it? What we need to do first is because we're using it in Unity, we actually need to add .bytes to the end of it, like so. And then we're going to drop it into the resources/Metaio folder, okay? And you'll see when it gets imported, it doesn't actually have the dot bytes at the end. It's perfectly fine. We're going to copy the name of this by clicking in Command C, and then coming over to the Metaio SDK and entering that into the tracking data form right here, like so. There you go. Quick and easy. Let me just make sure real fast that I'm on track here, creating a 3D map, adding the occlusion model. Perfect. So I had our 3D modeler here create two different files, this chess box here. We're going to import this just by dragging and dropping it into the primary folder here. Got the chess box. If we open it up, you'll see that we have two different FBX models. We've got this box and this cylinder. The box is the chessboard, and I had him make the ratio correct. It might be off by a factor of 10, but let's try dragging and dropping it in here. Yeah, that looks a little bit small. So first off, we're going to change the position. So right now, this is actually the top left corner, sorry, the perfect center of the marker, and we're going to change this to 10 and 10 and 10. There you go. So the rotation is a little bit off. And just do -90 and -90 to rotate it correctly. And then we're going to move it back to here, which is where the actual the edge of the marker should be. We're also going to add cylinder here and change the scale in the same amount, and again give it a rotation of -90. And we're going to bring this up there and position this where the two um, chess pieces were. Dunk and dunk, like so. And then we're going to, we need to associate both of these with the Metaio tracker. If they're sitting in the scene, but they aren't associated with the Metaio tracker, they won't actually be displayed on top of the marker. So that's something to be aware of. Okay, and we need to duplicate this cylinder and move it to the opposing corner, like so. These might not line up exactly with the pieces, but you can also see that they don't match the exact shape of the chess pieces. The width and the height is correct, which is the most important bit. It's better to have occlusion models that are a little bit larger than the actual real world content, rather than a little bit too small. If a model is walking here, so if we change direction here, so if the Metaio Man model is behind this, and there's an extra little bit of invisible Metaio Man off here on the left, that looks pretty normal, and the brain kind of comprehends that the Metaio Man is still behind that object. But if the opposite is true, and this is our actual 3D object, whoop, that guy's completely out of place. We'll put him in a correct position in a minute. But if the Metaio Man is actually clipping the other direction and sitting on top of this cylinder, then it tricks the brain, and you're not sure which one is in front of which one. So it's always best to have your models be a little bit on the large side. Okay, so let me just get a nice top-down view of this. And make sure this guy gets dropped down as well. Ah, I see they're connected. There you go. All right, now this isn't actually an occlusion model. If we were to load this into an augmented reality scene right now, we would just see a big gray box with two cylinders sitting on top of it. We obviously don't want that. On our Metaio developer portal, you can find this zmask.shader, which we're going to import right now into our Metaio folder. Dunk. And you can see that it's sitting right there as the zmask. What this does is it basically turns the object invisible and occludes any model which passes behind it. So we're going to apply this to all three elements, starting with the box by, um, sorry, actually I think I need to apply it directly to the material. Here we go. There you go. And now you can see that we can select it, right? We can select these different objects, but they actually don't show up in the scene. And if we focus on this and we rotate around, you can see that it actually cuts off the Metaio Man. So if we were to move our camera, you can see that that the Metaio Man is being occluded by this piece of geometry right here. Same thing with the box. If we move around, you can see that he is being cut off by these different pieces. So this is what's going to happen in the real world as well. If we move the Metaio Man around through scripts and he passes on the other side of the chessboard, it's going to look like he's completely cut off, which is exactly what we want. So setting up occlusion models is really easy. It's a little bit difficult to be completely accurate to the actual 3D models right now. We do have some tools coming out or planned that'll allow viewing and editing of 3D point clouds. They aren't available right now, unfortunately. So right now, sometimes a little bit of manual tweaking is necessary. Um, but you know, the building is quick. Okay, so we've added the occlusion model. So the next thing that we want to do is we actually want to be able to move the Metaio Man around. So what we're going to do is we're going to create a new empty game object. So game object, create empty. And we're going to call this our script holder. Now we're going to come over to the scenes folder, and I'm working in C#, so we're going to create a new C# script here. We're going to name this move Metaio Man. Proper capitalization. And we're going to open this script in MonoDevelop. This will take just a moment as MonoDevelop is loading. Yeah, so actually one of the questions that was asked before the webinar was launched was if it's possible to remove POIs if you create a 3D map and you notice that there's a couple of red dots in an obviously wrong location, if it's possible to remove that. We don't currently have the tool available online. We do have an internal one. We are hoping to be posting it to the help desk as soon as it's in a stable form though. So that's helpdesk.metaio.com, and you'll be able to see that soon. So keep an eye out there. Okay, so now we are going to create a couple of different things. The first thing that we're going to do is we're going to make a public game object, and we're going to call this Metaio Man. This is the object that is going to be manipulated in our script. Next, we're going to create a couple of buttons. We're going to call this float button size. And we're also going to create a public GUI style button. Okay, so this public GUI style is going to basically display an element on the screen. The button size is just a variable so that when we create 4 buttons, if we want to change the size or location of them all at the same time, instead of entering manual values, we're going to do this, and then we can adjust everything at the same time. But first off, we need to give the button a size. So button size is just going to equal 100 right now. And we're not actually going to use this update function in Unity because we want to display the buttons on the screen that you can press to make the Metaio Man move up, down, left, or right. The update function won't work. The update function gets called every frame, but it won't let you display any elements on the screen. So what we actually need to do is create a new void on GUI, like so, and return. And we're going to create 4 buttons now. So we're going to call GUI.button, And GUI.button has a couple of parameters. First thing we need to do is we need to give it a size. So we're going to say new rectangle. And let's see, so we're going to create, imagine this is a game and you've got like a little game control pad. You have an up button, a down button, a left button, and a right button. So we're going to start off by, let's see, we're going to start off with the up button. So let's put the location, 1, 2, 3, 4. Let's put the location 4 steps away from 4 of its own width away from the screen on the left and 4 widths away from its screen vertically. This gives us a little bit of space basically, and you'll see that we can place the buttons real easily this way. So what we're going to say is we're going to actually take the screen dot width and we're going to subtract the button size times 4. So this is going to be the width, the X location of our button. Same thing for the height. We're going to take the height of the screen, and we're going to subtract the button size times 4 as well. So these are the basically the X and Y coordinates of the button on the screen. And then we need to define the size of the button. So for that, we're simply going to say button size, which is the X size, and button size again, which is the Y size. So this would be like a square or a spherical or an even-sized button. If you wanted a rectangular button, then you would simply say like button size times 2. Okay, so this right here is the size of our button. We now need to, the first overload is a string, but we don't want any string for our button, so we put comma and then an empty pair of quotation marks. The second overload is the style. This is the actual image that is going to be associated with the button. So we're going to take this public GUI style that we created before, button, and we're going to put it right here. So what we also want it to be clickable, of course. So what we're going to do is we're going to say if GUI button. We're going to say the Metaio man game object right here. Okay, so Metaio man, and we want to change his position. So this is the up button, right? So we're going to say Metaio man dot transform dot position equals, or actually we're going to do plus equals, we have to say a new vector 3. So a vector 3 is simply a vector with 3 position or 3 coordinates, x, y, and z. And so what we want to do is we're going to add, I think this should work. I think this should be 1, sorry, I had this written down, comma 0, comma 0. So this should add 1 to whatever the current position is in the x location. 1, there you go. Cool, so when this button is pressed, basically the Metaio man is going to move slightly in a single direction. A better way of doing this would be to add a constant force, but that'll be covered in the next webinar. For now, we're just going to move him very simply by actually adjusting his position. Okay, so if we come back to the Unity scene now, we've got this script holder with actually nothing attached to it. We're going to drag the move Metaio man script over to associate it with the script holder. And you see now the 2 variables that we assigned public show up here. We've got the button and we have this Metaio man, which it says none. You see no game object associated with it right there. So we need to open up the Metaio tracker. We're going to select the Metaio man and we're going to drag that over and drop it right here in the Metaio man section. Now we need an image for the button, which we should have in our, oh, we don't have it here. Okay, we'll improvise. We're going to use the Metaio logo actually as our up button, and we're we're going to drop it right here. Okay, so now if we go to the game scene here, we're going to say maximize on play, and if we click play, not visible. Let's see, maybe the camera isn't set up. I probably know why. So we're real quick, we're just going to disable the box and the cylinder here to make sure that we're able to see the Metaio man. Let's see, nope. So you can see when we press play here, I'm going to focus on the GUI and we'll come back to the actual moving of the character in a minute. You can see that we have this this image that we assigned as our button. It doesn't look very button-ish, but it's what we had in the folder. It's sitting 4 widths away from the wall and 4 up from the base. So because we want to have a simple character capable of moving in different directions, we're going to reopen the game script here, and we're going to simply copy and paste this a couple of times, and we're just going to add a couple of comments here so that we keep track of everything. This is up, this is down, this is left, and this one right here will be right. And so for each of these, basically the logic is the same. What we need to change is we need to change the position here. So for the down button, we want its width or its distance away from the right side of the screen to be the same, but we want its height to be 2 elements lower, right? So we're going to change this to minus button size times 2. Same thing for the left and right. So for the left and the right, we want their height to be the same, but we want their distance away from the wall to be different. So the left will actually be minus 5, and the right will be minus 3. Okay, so we're going to do Control B to build this. We're going to come back here to the scene, and we're going to run it. And you'll see that now we have, okay. So our height for our 2 buttons actually needs to be dropped 1 down. So the height here needs to be 3, and the height here also needs to be 3. Okay, so Control B. If we run it now, you'll see that we have, imagine that these are nice looking directional arrows. And when you click either one of these right now, though, the exact same thing is going to happen. The Metaio man is going to move forward or up, which we don't want. So let's quickly reopen the script here. We're going to change down to -1, and we're going to change left and right to 1 and -1. There you go. So now each of these buttons, which are going to be displayed on the iPad screen, are all they each do something different, and they each have their own unique position. So we're going to Control B just to make sure that this is built. We're going to come back here. We're going to just reactivate these invisible elements, like so, or the occlusion elements. And we're going to go down to our script holder and make sure that everything has been assigned. We've got the logo assigned here. We have our Metaio man assigned there. And so if we build it, you'll notice that we have a couple of errors down here in the lower left-hand corner. These are all perfectly normal errors. These are simply because the Metaio script is actually trying to find an active device camera for a mobile device. And because we're obviously in the Unity editor, one doesn't exist. So whenever you're testing an augmented reality scene in the editor, you're going to see these same 5 or 6 errors. Don't worry about them. They're perfectly normal. Okay, but we don't actually have any script or compiler errors. So we're going to go to File. We're going to go to Build Settings. We've already changed this over to iOS, so that's fine. We're going to click on Build. Save that to our desktop. We're going to call this Unity Webinar 2. And because this is such a small scene, it should build very quickly. I'm going to quickly open this up in Xcode to show you how to finalize this. So right now you have basically an Xcode project with different folders, with different screens, info.plist. The only file that you need to care about right now is this unity-iphone.xcode project. So if we double click this and open up Xcode, you'll see that it opens up the project. If we select this here, so we're going to click on the Unity-iPhone icon here on the left, and you'll see that you have a range of options here: summary, info, build settings, build phases, and build rules. Again, most of these at this point can be safely ignored. We're going to go to build phases. We're going to open up this link binary with libraries, and then we're going to add the XML file. So just, sorry, let me walk through this a little bit slower. Click on the plus button on the lower left-hand side. Type in XML, and the first library that we need to add is the libxml2.dylib. Once that's been added, click on the plus button again. Click on the Add Other button here in the lower left-hand corner. Come up here to Libraries and select the Metaio SDK. Every time you do a completely fresh build, so not an overwrite build in Unity, but a fresh build from scratch, you're going to need to make sure that these two libraries are re-added. Otherwise, if you don't do that, so I just canceled right there. If you try to build, I don't have any device plugged in. One second. So a common uh, question that people come up with on the help desk is the fact that they're trying to build, but it isn't working. So if we tried to build right now with the one library missing, you're going to see in a second here, we're going to get all of these errors, and people see this and kind of get frightened. But all you need to do is click on the Add button, Add Other, go up to Libraries, and then select the Metaio SDK. And so if we build this right now, it should clear out all of those old errors and put the project on the device as a full application. It won't have a unique icon, but you can assign that here in Xcode. That's easy other stuff though. While this is building, I'm going to start answering some of the questions that have been asked during the webinar. Let me just open it up. Probably should have had this open earlier. Oh, just a moment, actually. I'll be right back. Okay, so let me just, usually we have a Google Doc for this, but unfortunately I'm currently locked out of that. So I'm going to answer your questions through the GoToWebinar control panel. This will just take a moment as we transfer those questions over. One moment here. Sorry for the delay. Gotcha. Okay, perfect. All right, just a minute here. Okay, so starting at the top here, the question was, you guys might not be able to see the GoToWebinar control panel, so I'm just going to read this out. In response to the point cloud, what shall I do if I get too many unwanted points, as those points are created from the background? Is it possible to delete the points after saving the 3D point cloud / tracking file? Currently, we don't have an option for that. We are actually working on a tool that will let you open up the 3D point cloud in a modeling program such as Blender or Maya, and actually delete individual points. You won't be able to modify any of the points, but you'll be able to delete any unwanted clusters. It isn't available to the public yet, but if you keep an eye on the Metaio developer portal, it should come out fairly soon. We've got it on the roadmap. Let's see. Here, since you guys can't see this, I'm just going to bring the PowerPoint up in the background. Oh, okay. um, Okay, so next question is, these occlusion models are close to the camera. Could you see some way of doing distant to the camera occlusion models? Use case would be giant Metaio man walking around distant buildings in a real city. Yes, that is possible. It would basically just be a question of scale. The biggest issue with something like that would actually be setting up the tracking file. It would be difficult, but not impossible. And again, because we don't have, because you're not able to currently directly import the 3D point cloud into Unity to actually see it, you would need to be really accurate with the dimensions of your models, because obviously just kind of trial and error going through that would take a while. Okay, let's see. Are there any more questions? Okay, next question. Is there an Android version of the Toolbox planned for development in the near future? Yes, it's on the roadmap. I don't think I can say officially when it's going to be released, but it's upcoming. Next one is concerning 3D tracking. Would it be possible to use a 3D model like OBJ FBX as tracking data instead of creating a point cloud? The advantages would be that we could use the same FBX OBJ file as the occlusion model. So the problem with that is that so the first answer is no, not right now. We have a couple of things on the roadmap which are similar to that, sometime in the future maybe, but right now, no. It would be nice to be able to line your OBJ up directly with your model, but the problem is that the 3D model doesn't actually really exist. I mean, your OBJ doesn't exist in real life. So if you have a 3D printer, what you could do is you could print your OBJ model and then create a 3D tracking file or a 3D tracking point cloud of your 3D printed model. And then the 3D model and your OBJ would line up very closely. But right now there's no way of simply importing an OBJ and creating a point cloud out of it, unfortunately. All right, next question. When I build the point cloud map, what does the percentage counter show at the top right represent? Percentage of what? That's the percentage of possible total points. So you saw in the video when we first started that we set the maximum number of points to 5,000. That percentage is basically just the percentage of points that you filled up. So again, I just want to reiterate that you don't have to get all the way to 100%. It can be kind of an arduous process when you get into like the 80s. As long as the plane model, which is included in the toolkit, is tracking well, your model will track just fine. Okay. How many point clouds can you use per application? Well, it really depends. You can have obviously multiple point clouds associated with any application. In Unity, I mean, hypothetically, you could have 10 different Unity scenes with each scene containing multiple point clouds. However, they all kind of exist independently of each other, and it's really difficult to get them all linked up correctly. So it's basically just a matter of size. The other thing is you can only have several per Unity scene, and so the user would have to basically select which real-world model they were looking at every time that they wanted to look at something different. But you can have multiple point clouds in each application. Is it possible to actually run the scene in Unity's editor and having all the models / scripts working without it looking for a tracking camera? From your demo earlier, I saw only GUI icons and a white background, but no Metaio Man model. So that actually leads me very nicely to our next subject. Right now, no, unfortunately. To actually visualize things, you actually have to do a complete build, which takes several minutes, and then put it on the device, test it out on the device, and if you need any changes, you then have to go back to Unity and make the changes there. But if we come over to the roadmap for a minute, uh, our upcoming release for the Unity SDK, the very the most important thing that we've been focusing on is creating a live preview using the webcam. So when you click the play button, you're going to see the any GUI elements like we already did, but then it's going to activate your device's webcam using the same tracking configuration file. So you're going to be able to point your device at a marker or at your desktop or whatever, and see everything live exactly like you'd like. This is coming out soon, but I don't think we actually have a live release date. While we're on the subject, currently the Metaio SDK has a single example scene, which you saw today. It's kind of what we were using as our framework. The upcoming release has quite a few more, much more detailed examples. So right now it's just a model and a marker. The upcoming ones are a lot more detailed and will really kind of help explain a lot of the common questions that people have. The final thing is a lot of times right now when there is an error in the SDK because maybe you don't have the correct bundle identifier, or because your application signature is wrong, or the tracking data isn't loading correctly, uh, the current error messages can be a little bit ambiguous. So we've really fleshed out the feedback and the log basically that you get when you're working with the SDK. So you're going to be able to quickly track down bugs much quicker. So that's all in the upcoming release. And with that said, I'll go back to the questions here. Um, Next question was, can we track multiple markers at the same time? For example, display 3D model Metaio Man for one marker and another 3D model for another marker, and so on. Yes, it is possible, but let me think off the top of my head. I believe you can only have one marker tracking at the same time. So you can have multiple markers in the same scene, but but only one of them will actually be displaying a model. So you can focus on one or the other, but you can't have many of them all basically interacting at the same time right now. Um, what is the game? Play in the same place where the 3D cloud is created? Yeah, so this was just a simple example scene. What would have happened is we would have had the Metaio Man basically sitting in front of the chessboard. And right now, we would simply be able to move him around, basically walk him left, right, forward, and backwards. And we'd be able to walk him around behind the chessboard. Unfortunately, my device camera link isn't working right now, so I can't actually show you. I'll try to take a video and upload that to the webinars page so you can see what we did actually in action. But this wasn't a game so much as more kind of explaining how these common game elements are all integrated together. So this would have been simply moving a character around. Later, you could introduce things to avoid a score system, similar things like that. Next question, getting back to my question, FBX/OBJ is tracking data. I've not understood why this is a problem. Why is it not possible? Well, it's basically we don't have the software developed that would let you simply turn one of these directly into a point cloud. The type of file that is created by our thing is this 3D map, which is a custom 3D point cloud system developed by Metaio. And we don't have any software that will just instantly convert an FBX or an OBJ into the 3D map. So there's no software, and there aren't really enough people interested in instantly turning a 3D model into a point cloud to make it worthwhile developing it. So right now, you basically can only create a 3D point cloud out of things that already exist in the real world. Does that answer your question? Okay, let's see. Are there any more questions? Just a moment. Let me check with our organizer real quickly. Okay. Okay. Will there be the ability to build standalone PC/Mac Metaio applications using Unity? Yes, I believe that's on the roadmap. I don't think it's not coming out in the upcoming release, but I think that is something that we're currently looking into. However, I don't think it's going to come out this quarter. It'd probably be in the mid future, not the near future. All right, I'm just waiting for additional questions from our organizer here. Can you create a point cloud in real time? Then, based on that pattern, can you create a scene in real time to interact with the points? That's not something, I don't want to give you a definitive answer because it isn't something that I don't know that you can't do it, but at the same time, I'm not aware of how you would go about from a user's perspective, how you would go about doing this. That's kind of what we're doing ourselves when we build the point cloud. I'm not sure if you guys noticed, but as the point cloud was being built, there was a little plane with a banner that was basically sitting right in the middle. And so for us, while we're doing the instant tracking, we have a 3D model sitting there. But as far as creating a 3D environment in real time and then basically dropping all of your game assets in there, on our end, it's definitely possible. But for users who are simply using the pre-existing software, I'm not sure how you'd go about doing that. Um, Send an email to the webinars at metaio.com and I'll look into it. I'll ask some of our more advanced developers and I'll see if they have any ideas about whether that's possible or not. Um, okay, next question is, your example was for a closed environment. How would we apply this to an actual AR game? I'm not sure I understand your question well enough to give you a intelligent answer, but I'm still answering all of these live. Could you elaborate on that a little bit, and I'll dive into it. The next question is, do you need Unity iOS Pro and Unity Pro to make an AR app with Unity, or can you just have Unity Pro? Yes, you do need to have the iOS, either the iOS or the Android license. Either of them will work, but uh, you won't be able to build a AR application for the Mac or PC currently, and you do have to have a Pro license in order to build on iOS or Android. So currently, yeah, that is kind of a barrier for people who like students who are interested in building an augmented reality game because it's not so much a holdup on our end, but you have to have the correct Unity licenses to be able to do all these. Okay. Uh, yeah, sure. So the next question, I'm guessing that this is relating to the game question before. Um, for instance, a user uses the camera to look at the table, and then if the pattern matches that of the table or desk or plane, then you can have the Metaio Man render on the surface. That's basically exactly what we were doing. For us, we were using that chessboard that we created, the 3D point cloud. That's what would be recognized, and then we'd be playing a game basically on that chessboard. Um, but you could, of course, do anything else. You could do regular tracking using like a magazine and create an interactive game there. You could take a 3D view of your entire desk, turn that into a point cloud, and then have people running around on your desktop. Or you can use a single object and basically ignore all of the other objects around and have the models associated with just that one object. So you could do an environment like a desktop, a single object like a chessboard, or a flat 2D image like a magazine or a book cover. And then you could have a game all basically, all of your models would be tied and children basically of those objects that you chose. Is there a limitation in Unity for multiple patterns or licenses? Um, I don't believe so, no. The pattern recognition is handled by Metaio, so that wouldn't be a Unity thing. Um, and no, once you're able actually to build as many applications as you want for free using our SDK. However, there is a Metaio-based splash screen and watermark. You need to pay to remove those basically. But once you've paid the fee once, you're able to build unlimited applications with our SDK with no watermarks. Um, can we download ZMask shader from http/dev.metaio.com? I know that it's up there somewhere. After this, I'll confirm, and if it isn't, I'll make a new post on the help desk. So this helpdesk.metaio.com with a link to the shader so that anybody who's interested in occlusion can use that. Next question. When creating the point cloud, is color information as well as coordinate information included to differentiate one item from another similar shaped item? Everything is rendered in black and white, but yes, shade and texture is included in the point cloud. However, if they have the exact same shapes, it might be a little bit touch and go. Best thing to do would actually be to try developing two separate point clouds and seeing if they can be recognized independently. It probably depends pretty significantly on the model or the marker that you're using. What is the behavior when the Metaio man reaches the chessboard? User pushes forward button. Does he go through the chessboard or automatically stops? Yeah, so right now the Metaio man would go directly through the chessboard. That's something that we could actually change by simply going in here and selecting. So if we select, for example, the box, you can see that we would go up to component add physics, and we add probably like a box collider, both to our box and then to our Metaio man. And there are different settings in here where you could say the Metaio man, if he comes in contact with it, he stops. If he comes in contact with him, he bounces off, like it was rubber. You can have a lot of different effects here. These are all kind of Unity specific things, and you can find tons and tons and tons of tutorials both on YouTube and on the actual Unity website as far as 3D model interaction and how you can have scripts do unique things. You could even have the Metaio man explode if he actually touches the box, but that would be a little bit drastic and violent. All right, let's see. Next question. I tried to build a collision with a sphere, but I noticed that it starts as soon as the app is opening. Is there a way to let it start when I point it at the marker? When you say a collision with a sphere, can you elaborate on that a little bit? I understand the gist of your question, but the specifics I'm a little bit off on. You should be able to I don't remember the exact syntax, but there is a function in the Metaio SDK where you can say if marker 1 is tracking, then do X. So I'm sure you could simply integrate that logic, and you could say only start this action if marker 1 or marker 2 or marker 3 is tracking. All right, let me see. I'm just waiting for additional questions here. Oh, cool. It seems like that's all of our questions for today. We do have another Unity tutorial coming next week where we're actually going to hopefully get into some actual gameplay. We're going to have a scoring system, we're going to have some particle emitters, and we're actually going to play around with some physics. Like, for example, in this one, the Metaio man would just walk directly through the object. In the upcoming webinar, we're going to have models interacting with each other, particle emitters, a GUI that reflects things about the scene. For example, like a scoreboard that counts up every time the Metaio man crosses a threshold or something like that. And we're actually going to get into more kind of gameplay elements, whereas this is more like a advanced features of the Metaio SDK. So looking forward to seeing you there. And if you have any questions that didn't get answered here or that you'd like more information on, feel free to send an email to, let me just bring it up, the webinars at metaio.com, and we'll try to get back to you as soon as possible. Thanks for your time, and I hope everybody. Oh, right. Also, sorry, we have a development contest here. Let me see if I can open the link real quick, which is pretty amazing, where we're giving out really great prizes for people that submit different augmented reality applications. We've got a game-themed one, overall popular one, artwork, and problem solving or learning augmented reality application. And the winners will actually be flown to Munich for our Inside AR, which is one of the world's largest augmented reality